Hi everyone. Let's say we have a graph where y represents a function of x. Well, let's estimate the domain, range, and function values from such a graph. Remember that the domain of f in the usual setup is the set of all x-coordinates of points we pick up on the graph. The range of the function is the set of all y-coordinates of the points we pick up on the graph. If you input x-coordinates from the domain, you press that calculator button F, the outputs are function values, y-coordinates, in the range. So you can think of it this way. You can think of, in the xy plane, you can think of taking a graph, projecting it onto the x-axis, smushing it onto the x-axis to get the domain, and then smushing the graph, projecting the graph onto the y-axis to get the range. Take this graph over here. Estimate the domain and the range of this graph. Assume that the graph extends as expected over here and over here beyond the window. Also, estimate f of 1 for me. And by the way, I say estimate because who knows? Maybe the y-coordinate here is 0.99. Well, no, it does turn out to be 1. We have a y-intercept at 0, 1, but I say estimate because, well, not everything's integer. This is 1. All right. That's the graph of y equals x squared plus 1, by the way. To estimate the domain, ask yourself, what are the x-coordinates we pick up on the graph? Well, assuming the graph extends as expected, we pick up all real numbers. But that should be expected because we have here a polynomial function. And that is the implied domain for any polynomial function. The domain we expect to be R, the set of all real numbers. This over here. Now for the range, we project onto the y-axis. 1 is the least real number we get in the range, and we get all higher numbers. So it looks like the range of f starts at 1, that's bracket 1, comma, infinity, parenthesis. So we've estimated the domain and range based on this graph. And let's estimate f of 1. Well, remember, function values are y-coordinates. So when x equals 1, what's the corresponding y-coordinate? This is the point 1, 2. Okay, on Desmos, here's the point 1, 2. It's on the graph. When x is 1, y has to be 2 on the graph. We estimate f of 1 equals 2. Now, in section 1.1, we talked about finding the domain of a function given its rule. Bear in mind that the range question can sometimes be a much harder question. Sometimes you cannot find the range of a function until you get the graph. Then you could find the range. Ranges are often harder to find than the domain. Next up, notice this graph does not have any x-intercepts. Why is that? Because this function value is never 0. Y is never 0 on this graph. How do we find x-intercepts and therefore zeros or roots for the function? Next time.